let's make sure this one works. Can you hear me in the back? Yes? Good. I think I need to reset the timer here. Otherwise, I'm Italian, so it will be super late. You have to tell me when to stop. And actually, I'm the last speaker of the day, which is usually a privilege given to either the ones that you really don't want to, share with the audience because everybody is leaving, or maybe just because there is drinks outside, so maybe they knew that the Italian was on stage. So, happy to be here. I just flew from San Francisco today to Los Angeles. And I want to talk about security, of course, specifically for the digital media space. And a first word of warning. Most of the time when I meet with customers, and I do this a lot, every time I go to conferences or I just meet with customers one-to-one, there's a lot of initial questions around security that usually are about, okay, I know how to do this in a traditional infrastructure. What's the difference in the cloud? And most of the time, people just don't know enough to be able to make a good decision. So the purpose of this very short talk today is also to give you the very basics that you need to know, at least enough to understand that it's a good value proposition. It's probably worth exploring. We always talk about this interesting concept, the shared responsibility environment. And we usually put this up front with customers. When we go there and we say, this is how we deal with security, this is how we intend security to be. We have our own responsibilities, and they usually are related to physical infrastructure, physical access to data centers, and of course network security as well. And then there are responsibilities on the customer side. And the reason for this is that we want to give you freedom and control. And in order to give you control on your resources, and that control, we're going to talk about it even later a bit more in details, that control, of course, comes with some responsibility. For example, one of the most common questions is around OS security. And we divide, when we say OS, operating system, we usually can mean two things. One is the guest operating system, is the one that you can launch on EC2. And one is the host operating system, which is essentially the base layer that we control. And when sometimes customers interact with us, they might say, okay, what can you do on our machines? I want to know exactly if you can access my machines, if you can do anything on my machines, etc. We don't have any access to your machines whatsoever. You are fully responsible then for the security on those machines. So you have to patch those machines. You have to make sure that you configure your firewalls and your other protection mechanisms very well. And of course, this is the price to pay to be able to have full control on that infrastructure. So we believe that this is an approach that most customers, of course, initially start to understand slowly because they are used to have those packaged solutions in which they just pay and they receive something of which they have no control or almost no control, to this model in which we tell them, we know exactly what you need to run your business. You need a set of building blocks that you can assemble together and then create the infrastructure you want and the architecture you want, also from a security perspective. And then, of course, with this, it comes some responsibility. And of course, we want to share two main things with our customers because customers are not forced to tell us what they do on AWS. We don't even ask them until they come to us and say, I need some guidance or need some best practices on how to implement security very well on AWS. But on our side, we always want to be very explicit and we want to really communicate enough to our customers in relation to security because we want to make sure they know all they need to know to then run their business properly. And we share two main things. One is documents, content, best practices, white papers, etc., to essentially educate customers on how you can do things in the cloud and how you can secure your environment in the cloud. And the second thing, of course, is related to certifications and, of course, third-party audits, etc. So this realm here, certifications, compliances, etc., is very well explained in the main section of our, the main security section of our website. If you go to aws.amazon.com/security, you can download, for example, the risk and compliance overview white paper which is a very good starting point for this. And again, certifications are divided into two subsets. One is the certifications that you essentially inherit by default just by using AWS, such as ISO 27001 and all the others that you list there. And then there are other certifications that you can obtain by following a specific process, again, on top of AWS. But for those certifications to be up and running, of course, there is some work to be done on your side. A good example is HIPAA for healthcare. We can't give you a HIPAA-ready environment because on your side, since you manage data and you take full control on that data, so the privacy of your customers is, of course, very safe. In that case, you have to perform specific operations to be able to use AWS as a base to obtain HIPAA certifications on your virtual infrastructure. Let's dig a little bit deeper now. Let's talk about some of the security aspects of the AWS cloud. We start with physical data center security. And most of the time, I would call it maybe not a mistake, but maybe an assumption that most people have initially. Whenever you think of a remote service, something that is far away, you usually never think of physical security at first. Because you think it's remote, it's far away, I can't touch it, I can't see it, so physical security shouldn't be an issue, of course. But instead, it's not likely the case because physical security is of utmost importance. And of course, we built data centers and we took care of data center security even before AWS was born with Amazon.com. And we have a long experience that, of course, we put into use in making sure that the physical security of our data centers is top level. So we take care of physical security, perimeters. Every time our personnel enters a data center, it has to authenticate with MFA, multi-factor authentication, at least twice before being able to do any operation within the data center. And any physical movement, any physical activity within the data center is tracked and logged and monitored and, of course, audited. And, of course, this is also part of the certifications that we have and that we disclose with our customers. And at the same time, we also have essentially a mechanism that grant permissions to Amazon employees to perform specific operations only when they need to perform that specific operation. So, for example, if you need to enter a room in which there are many disk drives, you can enter that room only at a specific time when you have to perform operation in that room. And if you get out of that room, of course, you would track the time at which you left the room and everything else. So all of those operations, essentially every task that is performed inside our data center is constantly tracked and monitored. If we look at the, let's say, the virtualized part of our data centers, what you see as a virtualized part, of course, there are physical machines. On top of those physical machines, we run a hypervisor. And on top of that hypervisor, we run guest operating systems. And those operating systems, those virtual machines are what we call Amazon EC2. It stands for Elastic Compute Cloud. And on Amazon EC2, of course, we have multiple levels of security. So, for example, the Bastion host is the main way that Amazonians have to access the host operating system. And it's, let's say, a well-known mechanism to ensure that authentication to access a specific resource is not managed by the same machine or the same set of machines on which the resource runs, but instead it's a specific machine meant to be used only for authentication. It means that you can, of course, strengthen the security of that machine in a much, more efficient way and durable way. So essentially, those machines are the ones that make sure that authentications, that operations, and any type of log-in, either a person behind a machine or API calls, is, of course, taken care of properly. And then, of course, the guest operating system, the one that you see and that you touch, is customer-controlled. You have full admin access or root access if you're using Linux machines. And AWS admins, so the personnel that has admin rights at the host operating system level doesn't have any access to those machines. And the reason is simple. When you create credentials to access those machines, it's essentially two parts. You keep one of those parts, and the second part is kept by Amazon Web Services. You can authenticate only using both parts together. And AWS admins don't have access to that part, to your part. And then, of course, the firewall, the stateful firewall, it's a firewall that by default is built in every EC2 machine. It's essentially called security groups, and it's a firewall for inbound traffic. By default, it's closed on all ports. Sometimes customers launch a machine, try to access that machine, and they say, oh, I can't access my machine. What's wrong? Well, the firewall is by default blocked on all ports. You have to explicitly open specific ports. And there is something that it's not even covered here on the slides, something called the Trusted Advisor. It's a functionality available for paid support users, from premium support users. That is an automated set of tools that essentially detects potential problems or potential issues within your account from a security standpoint and gives you suggestions on how to fix it. For example, if you open a port used to log in into your instances to everybody on the internet, we tell you that might not be the right approach. It's better to limit access from a specific IP, which might be, for example, the IP that originates from your office or from your facilities. And then, of course, every access, every operation performed essentially on the APIs that AWS provides is always authenticated and secured. This diagram here shows you the different levels that I was briefly talking about before. So the physical infrastructure is here, and then you have the hypervisor there that creates, of course, that exposes virtual interfaces. And then, of course, those are the ones on top of which the guest operating systems run. But, of course, it's not just CPU. It's not just processing, but it's also storage and memory. And again, you don't touch directly the physical RAM or the physical memory or the physical disk drives, but we created a proprietary level, a proprietary layer that essentially virtualizes those resources and exposes them and makes them available to your machines. And this level, of course, is designed to make sure that security is of the highest level. For example, when you launch a new instance, we assign some storage to run that instance, and that storage is completely wiped out using specific procedures before you're even able to touch that virtual storage. So you can't even try to use some techniques that might allow a user to read what was on that disk before the disk was assigned to him. This thing is simply not possible. One example, now I'm trying to dig a little bit deeper again. Of course, I don't have time to cover everything, but this is probably a good example. Storage decommissioning. So most of the time when you deal with physical infrastructure, you never think of the moment where you will need to decommission your storage. And storage decommissioning can be painful, especially if the data that you're storing is sensitive or has IP rights on top of it. And when you arrive in that situation, when you start to do some calculations and things, you realize that it's quite expensive to decommission storage in a proper way. And sometimes you are required to do so, even if you don't like the bill. So in the case of Amazon Web Services, you don't have to take care of anything because you see virtual devices, you don't even know how old the disk you're using is. And of course, once a physical disk reaches end of life, we decommission that disk using specific procedures. Those acronyms, I don't even want to try to read them. The DoD 52220.22-M and others. And on top of this, this is essentially, just to summarize at the risk of being approximate, it's essentially multiple random writes on top of those disks to make sure that not even with the best techniques you can read the data that was on those disks before, but even on top of this, we then finally DDoS and physically destroy those disks. And when I say physically destroy, I really mean physically destroy disks. So when a disk reaches end of life, it's properly destroyed and, of course, taken care of. And another point that I want to make here is that we recently launched a new service called Amazon Glacier. That's the reason of the picture here. So Glacier is what some people call a cold storage solution. Essentially, there are many situations in which you want to archive storage. You don't necessarily need to access that storage immediately, so you can wait a few more hours to retrieve data from that data set, but you want to try to minimize the amount of money that you pay to store that data. So cold storage is the realm of tapes and similar things, and we came out with a solution called Amazon Glacier, which is essentially an amazingly designed and engineered solution that allows you to store data for 1 cent a gigabyte per month. And when you need to retrieve that data, for example, for disaster recovery purposes or because for some specific regulations, you need to retrieve logs of transactions dated 3 years ago, whatever it is, you can, of course, initiate the retrieval of that data. And within the first 4 hours, we will start sending you data back. And by doing this, by giving you a delay in receiving data, we were able to engineer things in such a way that allowed us to save money and to pass those cost savings to our customers. So this is important because even in the case, the data life cycle, when you think of your data from start to end, from generation to destruction, it's very important to realize that Amazon takes care of your data life cycle from start to end. And there's no hidden cost that you will discover eventually. It's all there. One tool that is very important to mention is IAM, the Identity and Access Management. So we talk about security, and of course, when we talk about security, it's very important to have something that allows you to define roles, users, groups, and specify permissions and access control for those people the way you want it. And of course, this also implies being able to control the credentials of those people, being able to revoke credentials if needed, being able to increase or decrease permissions and control depending on the specific role or a specific time. And most people realize that even within the same company or organization, you need to have specific roles and to be able to assign responsibility to specific users, even if you trust everybody. And the reason is simple. If something goes wrong, you want to know that that specific credential was the one that initiated that thing that caused your problem. So you want to be able to identify who caused that problem in case there is a problem. And those things are, of course, needed. That's the reason why, for example, every employee in any major company needs to authenticate with his login and password and maybe other meanings of authentication. It's the same concept here. If you have people that have access to your data, to your assets, you want to be able to manage those people and their credentials in a proper way. Now, I know I'm the last speaker, so I'm trying to speed up a little bit. I don't want to have you fall asleep too early, otherwise you would skip the wine outside. So I will give you a few more slides before we end, and it's surprisingly a simple media workflow example. We're going to quickly cover 4 parts of this architecture here: the ingest part, the storage, the processing, and the distribution part. So we start with ingest. So we provide multiple ways for customers to upload data to Amazon Web Services. One is, of course, using S3 or other storage options, and every upload is encrypted, uses SSL endpoints. We also integrate with software, with SDKs, for example, with the Java SDK, to allow you to integrate those security mechanisms within your own software. And of course, we also provide something called AWS Direct Connect, which is a direct peer connection to Amazon Web Services. And we also allow to use SQS, which is the simple queue service, a queuing mechanism, to essentially use AAS IAM-based access. And if you have additional questions on this, we can talk later in more detail. The storage part, of course, S3, the simple storage service, is full of security features. You can encrypt files even on the server side. You can use versioning, and you can also use multi-factor authentication delete on those files. You can look at the detailed access logging to really track what is going on with your files, who has access to those files, etc. And you can also control the granularity of access that you give to your colleagues, to your partners, etc., because you can control access even to the level of the individual item, not just the folders, or as we call them, buckets. A word on virtual private cloud. This is a service that we started offering a while ago, about 2.5 years ago. And the virtual private cloud is a way for you to isolate a portion of the cloud, of the Amazon Web Services cloud, and essentially make it its own subnet. So for what matters to you as a customer is the equivalent of having your virtual private cloud within a larger cloud, the Amazon cloud. And of course, VPC, or virtual private cloud, is particularly important whenever you need to run processes, whenever you need to use CPUs or virtual servers on Amazon Web Services, because even if you can easily launch machines, let's say outside VPC, so in the normal Amazon Web Services cloud, if you want to create a very secure environment, what would you do in a normal physical infrastructure? You would divide your different areas in different subnets and isolate them to make sure that whatever problem arises in within one specific area, it doesn't propagate to other areas. And this also includes protection of data, protection of access to resources, etc. So the same thing applies in the cloud. You can create those subnets, your own subnets. You can have essentially an almost unlimited number of VPCs within one account. And then you can create, by default, the VPC doesn't have any access to the internet. So the only way for you to access VPC is through a dedicated VPN connection, encrypted and secure VPN connection. But then if you want, within VPC, you can create an internet gateway, which allows you to allows those machines to get to the internet, and potentially you can even create a gateway to allow connections from the internet to your VPC, or even between two separate VPCs. Essentially, you have the flexibility to design the network topology that you need to implement the security that you want. Distribution, I don't want to talk too much about CloudFront because it has been covered already well enough. The only thing I want to point out here is that in terms of security, there are some very important aspects that appeal to many, usually enterprise-grade customers. For example, the fact that you can have a private content option, so you can limit who has access to specific content. You can look at very detailed access logs and, of course, use, for example, EMR as a way to analyze those logs and extract interesting information about the behavior of your customers, for example. And then, of course, you can also have a secure HTTP or HTTPS connection to your assets on CloudFront, etc. And there is much more related to CloudFront that I don't want to cover today because of lack of time. But essentially, we started CloudFront. It was almost 3 years ago, actually, in November 2009. And then we kept building and adding additional features, especially from a security perspective, because more and more customers started using it also to distribute content that, of course, has value. And last but not least, we believe that a good security practice is to cipher, to crypt all sensitive traffic to and from your cloud, whatever it's a VPC or a normal Amazon Web Services cloud. And of course, we support VPN tunnels, we support Direct Connect, and essentially many ways for you to treat this as simply an extension of your data center, with the advantage that from a security standpoint, instead of you in the need to invest in multiple people to take care of all the security aspects of your environment, you can essentially benefit from the economies of scales and the investments that Amazon put into the security aspects of AWS. So despite being Italian, I was less than 30 minutes long because I really wanted to give you a chance to either ask questions or go and have some drinks. I don't know what you prefer, but if you want, we can strike a deal. We can have 2 quick questions and then everybody can leave. What do you think about it? Okay, one question there. Yes, the mic is coming.
Is there a plan to have ARNs for Amazon EC2? I know you spoke about IAM, but today actions can be limited, but not on specific objects.
Okay, that's a common request that we heard, and we cannot disclose anything on the roadmap or what's going to happen. But usually what I can say is that common requests are very well taken into account by the product teams, and usually if there are customers asking for it, there is essentially a good incentive for us to implement those. But officially, there is no roadmap or a date that I can share with you. Another question, one last question, yes?
We are negotiating with Hollywood studios rights to content. Our media platform is using your cloud-based systems. If I answer the question, what protects our content security by pointing finger at Amazon's security media library, what would be the reaction? I assume that positive one.
Yeah, so I can joke and say, you can tell them that an Italian is taking care of the security, and usually we can make offers that people don't refuse. But besides the joke, as you can guess, this is a common business scenario because many customers like you start using Amazon Web Services, and then they start talking to their customers and they say, we're using Amazon Web Services. Is it secure enough? So we built, well, we have 2 things, 2 resources that you can use. One is content that you can use and share with your customers. The second one is if you get in touch with one of our sales managers, even better, directly to a solutions architect. We have solutions architects that are specialized in the digital media space, and they can give them very specific answers, because usually there is a security guy on the other side that knows a lot about security, and sometimes you don't know the answer to a specific, very specific, detailed question. So in that case, you can get back to us. We can even usually arrange for a meeting together, so we can sit all you, your customers, and us together and answer their questions. And we try to do this to help customers essentially build trust in the AWS cloud. Okay? One last question, quick one. Yes?
You mentioned the security of the virtual machine, that the administrator of the host doesn't have access
to the guest host.
to the guest host.
Yes.
What happened with the router, switches, all the network elements? Do you have a physical virtualization of them, or is a logical?
Okay. It's a good question. So let me summarize the question, because people didn't hear the first part. Essentially, guest and host operating system, there is a clear separation, and AWS admins have access to the hypervisor, but no access to the guest operating system. The question is, what happens at the network level? So essentially, there is a general, not just for AWS, a general approach to security in terms of execution of processes. And there is a concept called rings from 0 to 3. So ring 0 is the one with the highest privilege, then ring 1, ring 2, and ring 3. And this essentially, ring 0 has the ability to do anything. Ring 1 has less privileges, and so on and so forth. The host operating system, the one that we manage, the one that runs on the hypervisor, is at ring 0. It can do anything. But doesn't mean that AWS admins can do anything, because we have tools and we have logs, and we log any activity. So our people have to essentially perform specific operations. And when we have critical operations, there is never a single person doing that. There is always at least a second person supervising what's going on. Second, since the guest operating system is at ring 1 level, it doesn't have all the privileges. For example, talking about network, think of a network interface. Think of an Ethernet network, for example, interface. The physical one is controlled by the hypervisor. You, as the guest operating system, you will see a virtualized one. And because you don't have direct access to the physical one, for example, most of the common network attacks in a specific intranet, for example, IP spoofing, port scanning, etc., is simply not possible within AWS because the hypervisor will detect this type of attack and stop it. Instead, if you have control of the physical infrastructure, you could potentially do those types of attacks. That's why we, for example, talk about the instance isolation. The fact that any virtual machine that you use is really isolated from all the others. And even if there is a malicious activity going on in one EC2 machine, that person can't touch anything of the other machines because the hypervisor has higher privileges. And we, of course, make sure that the network layer is controlled and secured. And of course, we also have we run some statistics and some comparisons. And whenever we detect an anomaly, for example, an unusual amount of traffic on a specific port or those kind of things, we, of course, have alarms that pull up, and then our network security guys will take care of it. Okay, one last question. Can we do one last question? Yeah, one last question. Yes?
Does AWS have an audit trail for IAM users down to even the level of modifying security groups?
So we don't disclose this detail. I'm not sure if we are able to disclose this detail with the... Yeah.
Sorry, available to the AWS admin. I mean, to our account. Like, is there an audit trail that we could download that would tell us the actions that an IAM user took?
You as the user,
yes,
related to your IAM.
Mm-hmm.
We don't provide that. I'm not sure if you can request that to be provided to you, but we don't provide it by default.
Okay, I think I left a feedback on for the request in the forums.
That's great. I was going to say, if it's a specific request, reach out to me or use the feedback, because I know that specifically the IAM team is really keen on listening to feedback.
Great. Thank you.
Okay, thank you very much. Thank you very much. I think you have to say the last few words. Yeah.
Simone.
Thank you.
Thanks so much, Simone. Well, that wraps up our event today. Thank you so much for joining us.